Okay, let's make a new folder here. Call it linked list. Add a new file. Linked list.c. New file linked list.h. Alright, so pop into linked list.c. We're going to include a couple libraries here, so let's include standard library and include the standard input and output library. Include. Alright. So we need to create our own custom type here of a node. So we'll make a struct node. Within struct node, and at the end of a node you need to close it off because use a semicolon. Alright, at the in the struct node we're going to store our info. That's going to be an integer type. And then we need a link to another node. So a link to another node is going to be a struct node pointer type, right? Well, no. Yeah, pointer type. Which is basically an arrow going from one node to the next. So we have, if you want to visualize this, we have like a piece of data that we can store in here called info, and then we have an arrow that we can shoot off of it and go to another node. Alright, so we're going to need a couple functions. Struct node. Let's create a list. So in this coding exercise, let's create a list. Let's handle the two cases where we insert an element in an empty list, and then we're going to need to insert elements after the first element. So all we're going to do is create a list, insert something in it, and then continue to insert things after that, and then show what's inside the list. So we need 4 functions: insert, create, list. And it's going to take a struct node start, the thing that we start with. So when we begin our program, we're going to make that null, and we're going to pass it into this function first, and then struct node insert in beginning. We're going to take a piece of data, and the same thing, struct node start, struct node. Each one of these is returning a struct node because I'm going to keep on reassigning start throughout the program. Insert after in info struct node start. Then finally we want to show the list. So alright, let's make our main. So to begin our list, we need that first little square. That's our starting point. So we need to declare type. We need to declare our starting node, our start, struct node start, and we need to allocate some memory for this before we begin. So start equals struct node malloc memory allocation, and it needs to be the size of our type struct node, so we can store a link to the next node and some info in this little box of memory, this little node. We want to start it off as null, so our list is going to be empty and start's going to be null. And then we're going to create a list. And then we're going to show the list once we're done. Okay, there we go. Our whole entire program's done. Oh, whoops, nope. We need to actually put in the definitions for these functions. But hopefully you can see that all we've done is we've started with a simple goal of creating a program, and now we just have to figure out the pieces in between. Right? This is all we're doing. We're just going to create our start node, and then we're going to create a list, and then we're going to show it. So our program is pretty much done. It's just us figuring out what goes in between. So let's go ahead and add in the other missing pieces. In Visual Studio Code, if you hold down Control and Alt, you can do multi-cursor selection. I'm going to hit the up arrow, and then I'm going to hit the down arrow, and the down arrow. Now I have the endings of all of these functions selected. I'm going to hit backspace, type in my first curly brace, gives me my ending curly brace, hit enter, move the arrow down one more, hit enter. So that's multi-line edit in Visual Studio Code, one of the features I really like in this editor. Alright, so let's begin by filling in the blanks for create list. So to create a list, we want to insert something in the beginning, so we want insert in beginning, and we're going to want to insert some info and reassign start. Okay, so we don't have info, so up at the top I'm going to create a local variable to this function info, and this is going to be for the case when the list is completely empty and we got to insert our first element. So we're going to do printf, enter the info for the first node. And now scanf, we're going to use scanf to get the user input. We're going to use %d for integer formatting, pass in the reference to info. So that's going to let us insert an element into the first part of our list. So we don't want to just insert one element in our list. We want to insert an element and then continue to insert elements after that. So for int I equal to, let's skip over 0 since that's already taken care of, I less than n, I plus plus. Now we need to fill in the blanks. So printf, we're going to need n, right? So we never got the size of how many elements the user actually wants to input. Let's go back up here, add another local variable, printf, please enter the number of elements that you would like to insert. Scanf, let's get that input from the user, so %d n, and it needs to be referenced to n. Okay, so we're down here at this loop. We're trying to get each element that the user is going to input. So please enter the info for node %d. Let's use a formatted string, and we'll pass it I. So on every iteration, we don't want it to just be I, since that's going to look like 1, and we already filled out 1. So this loop is going to start from 1. So what's going to happen is we're going to get please enter the info for node 1, and the user is going to be like, wait, I already entered the info for the first node. So rather than doing I, instead of doing please enter the info for node 1, node 2, node 3, node 4, node 5, we want it to be node 2, please enter the info for node 2. There we go. Please enter the info for node 2, because it's going to be 2 on the first pass, then it's going to be 3 on the on the second pass, then it's going to be 4 on the third pass. So this will look correct to the user. Alright, let's get the input from the user. And every time that we do this, we've got to reassign start our list. We're going to be modifying our list each time. So insert after info start. Hey, look at that. Now we're done. Now we did it. Oh, whoops. Nope, we still got to do these ones. But you see, we're iteratively going through the program, figuring out the pieces that we need to put together to create a little program that will create a list, show the list. So in create list, we have to insert something into the empty list, and then we have to continuously add elements after that until we reach the maximum size that we got from the user. Okay, so for insert in beginning, we talked about this case in the theory section. So we're going to create our little square temp that we can store a link to and some info. Since temp is a new node, we're going to need to allocate memory for it. Temp equals struct node malloc size of struct node. Okay, and let's store our info in it. So info, we're going to get info, and then we're going to store it in temp's info, which is going to be temp's info member. Okay. So since this is in the beginning, we don't have to worry about looping over anything. All we're going to do is we're going to take we're going to take temp link, and we're going to point it to what start is pointing to, which should be currently null. So up here, we point start to null. So all we're doing is we're making that arrow on temp pointing to null. That's all we're doing. Since on the first pass, starts null here, we pass it into create list, comes into create list, then it hits right here into insert in beginning, so it should be null. And then we want to reassign start to point to temp. So that'll give us our first little element inserted into our list. We want to return start. So we've taken care of all the stuff up to here. Now for insert after, we're going to follow a really similar pattern for getting it started. We're going to create our temp node, and we're going to assign info to it. The thing is, we're not just going to use temp, we need to skip to the end of the list, so we need another pointer, p. But p doesn't, we're not going to be storing any data in p. P is just going to be a little guy that's going to bounce down the list until we get to the end, and then we're going to use p to add our temp node. So p should start at start, and this little pointer's got to skip to the end of the list. So while p link does not equal to null, is not equal to null, okay, is not equal to null, p equals p link. So what this is going to do is it's going to bounce down the list, boop, 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 until it hits null. And then once it hits null, we know we're at the end of the list. And then we just make p link. We're going to add something to it. We're going to add temp to it. So now p link is no longer pointing to null. It's now pointing to temp, this node that we just created. And we need to reassign temp link to null. So now our list still ends with null. And then we return start. Okay, so since we just figured out how to do this, that means everything's taken care of up to here. And we're supposed to return start. So once this is all done, return start. That's going to take care of create list, the last thing we need to figure out is how to print everything out. So we'll modify show list. We just figured out how to loop through the list, so let's use that to figure out how to print everything in our list. So if we want to print everything in our list, we'll use struct node start. So we're going to declare a pointer p. That's the thing that we bounced through the list with. And then if start is equal to null, let's handle this null pointer. We're going to say printf the list is empty, and just return if that's the case. Otherwise, we're going to set p equal to start, just like we did for inserting after. So up here, p equals start. And we want to go all the way to the end of the list. So, well, p is not equal to null. Notice that's p not equal to null, not p link. We're going to print out the info stored in each section. So printf %d, so we're going to print out the info stored, so integer formatting. How do we get the info that's stored? P arrow info. And p equals p link. And that's going to take care of it. So this should work. So let's drop down into the terminal here. So ls linked list.c g++ linked list.c -o proc. Oh, we got our first problem. Create list. So I'm going to pop up here and I'm going to go Control G and I need to go to line 20. And yep, I forgot an E. So change that. G++. Okay. Create list. Up here. So up here in line 9, I have an error. Got to make this into create list. And down here, I need to make this into create list. Okay, so that should take care of our errors. So that compiled. Let's run it. Goes into the number of elements that you want to insert. 5, 1. Well, the formatting on this let's format the string so it's actually printing out on a new line each time. So let's go back up to the code in line 37. \n. So that's going to give us a new line each time. Let's recompile it and run it. So 5, 1, 2, 3, 4, 5, and we get our list. So I hope that makes sense on how to handle the cases of inserting elements into a list and showing what's inside the list. Keep on working with linked lists and improve our understanding. If you like this video, I'm making lots of videos on C programming, so if that's something you're interested in, please like and subscribe. You'll see more. Thank you.